So constant of proportionality. Constant of proportionality, you are identifying the proportionality of a table, a graph, or an equation. So we talked about it yesterday. To be proportional, you had to be able to cross through the origin and create a straight line in that process. So the origin is a very key part. Being a straight line is a very key part. They're all linear relationships, has to cross through the origin. There's a specific reason why it crosses through the origin. It's because it has a constant rate of change that is equivalent or equal to its proportional relationship. If you create a problem that does not cross through the origin, then you have a constant rate of change that would not be equivalent to a proportional relationship, meaning that your y over your x is not going to be the same thing as what your change of y over change of x is, and the y over x value is not going to be the same throughout every single point. We're going to take a look at what that means here in a second. So just a couple quick reminders. You've got your tables, the way that they're set up. You've got vertical tables versus horizontal tables. Just keep that in mind, that we always have our x and our y corresponding left and right side. If it's a horizontal table, typically we put the x on the top and the y on the bottom. So for proportionality, again, what I was telling you guys when you were doing your IXLs, a lot of you were making the mistakes where you were just picking a point on the graph and you were putting your specific y value over your x value. That is not constant rate of change. That is checking a proportional relationship. So we call that K. K should look familiar. Where else did we use the value K in our unit last unit? Who remembers? Nobody? Scale factors? Your scale factor was called a K factor? Oh yeah. Scale factors. Scale factors are K. Scale factor is also a type of proportional relationship, meaning that you're taking a small item or a big item and you're scaling it either up or down by a scale factor of K, making it proportional in its size. So proportionality is always that value of K. When we're talking about it as a graph or as an equation, we're focusing on a specific value of y over its corresponding value of x. Okay? So here, all proportional relationships are written in the following format of y equals k times x. K times x. Okay? The reason that it's able to start at 0 is because if you're adding or subtracting anything from it, that value is 0. So it's always going to be y is equal to k times x, where k is your proportional relationship. So if we're taking a look here at this table, we have hours and we have mileage. Remember that the hours is going to represent our x value, and the mileage is going to represent our y value. And we want to know what is the constant of proportionality. So they're already telling us that this is a proportional relationship by asking us what is the constant of proportionality. So constant of proportionality is going to be equal to your k over your x. I'm sorry, your y over your x. So I'm going to use purple to represent k. And when I'm setting this up, I'm going to set it up as fractions. And I'm going to go ahead and show you in all three formats. It doesn't matter which point you pick, it's all going to come out to the same thing. If I decide to do 120 over 2, or if I decide to do 300 over 5, I could do 540 over 9. They all are going to come out to exactly the same thing, which is 60. Every single one of these is going to come out to the value 60. Okay, so that means that our proportional relationship is 60, and then we always relate it back to the categories, the labels. It's 60 miles per 1 hour. 60 miles per 1 hour is going to be your constant of proportionality. Now, if I were to go ahead and write this as an equation, my equation would literally be y equals 60x. And that's it. That's your equation. which is really simple when they give you an equation and they just say, hey, what's the constant of proportionality? If it's set up like this, then your constant of proportionality is the only number that you see. That's it. All right, for problem number 2, like I said before, if they give you an equation where you have it set up as y equals a number x and nothing else, that number represents your proportional relationship. So Neil's practicing for his typing test. The equation is y is equal to 45x, represents the total number of words y that he can type in x minutes. So what is the constant of proportionality? Just the 45. He can type 45 words per minute, 1 minute. That's his constant of proportionality. Go ahead and do 3 and 4 on your own, please. All right, let's go over it. Problem number 3. Distance y traveled in miles by the Tran family in x hours is represented by the equation y is equal to 55x. State the constant of proportionality. What is that going to be? Constant of proportionality. Logan, why don't you tell me what it is? Y is equal to 55x is an equation. I want the constant of proportionality. So remember, constant of proportionality is the number in relation to what it represents. So 45 words per 1 minute. What is that constant of proportionality going to represent? Pardon? 55 hours? Whew, that's a long time to travel. It's 55 what? Miles per what? Per hour, per 1 hour. Okay, it's always going to be in relation per that 1 in this situation. So we've got the 55 miles per 1 hour. 55 miles per 1 hour. Guys, the reason that it's going to be miles per 1 hour and not hours per mile is because, again, it's always going to be y over x. Okay, and our y is representing the distance that you're traveling, and your x is representing the hours. So you're saying it's this amount of y's per this amount of x's. So if it's a whole number, then that means it's a whole number over 1. That would be 55 over the 1. So 55 miles over 1 hour. Okay? Let's take a look at problem 4. The number of calories y that x cookies have is represented by y equals 125x. What's the constant of proportionality going to relate to? Merrick? Good. 125 calories per cookie. Again, calories is your y, which we know is going to be 125, over the x, which is your number of cookies. And since it's a whole number, it's just that one cookie. Okay, so it's just 125 calories per cookie. Now, it's not always going to be a perfect whole number. Sometimes it might be like 3 over 2. So it would be 3 of your y's for every 2 of your x's. And that would be your constant of proportionality. Okay? Go ahead and flip it on over to the back. So it's not always going to be constant of proportionality from equations. It's not always going to be constant of proportionality from a table either. Sometimes it's constant of proportionality from a graph. But again, remember, if it's a proportional relationship, then that means that graph has to cross through the origin. Not only is it a straight line, but it's going to cross through the origin. And all you would have to do in this situation, when you know that this is a proportional graph, you just pick one point. Just one. Doesn't matter which one you pick, as long as it's not the origin. Can't pick the origin because the origin is different. You can't do 0 over 0. You have to pick a non-origin point on your line. So somebody tell me one of the points that they want to pick on here. Hassan? Okay, the 1 and the 5. Sure, let's go with that one. That's a 1, that's a 5. So what we would be doing, again, is setting it up as y over the x. So based off of what he just picked, he wanted to pick 5 over 1. Pick another point. Somebody tell me another point that's on the graph. Leah. Okay, so 7 and 35. So she picked this point right here. 7, 35. So let's go ahead and see. We're going to check to make sure that they are the same. We put the y value, which was 35, over the x value, which was 7. Are those going to be the same? Are they equal to each other? Do they both equal the same thing? Yeah, they both are equal to each other because they both come out to equaling a constant of proportionality of 5. So your k factor is 5. And again, if I wanted to write it as an equation, the equation would be y is equal to 5x. If I relate it back to this information, how would I relate it? How would I state it as it's this per this? Richard?
5 gallons per minute.
Very good. So it's 5 gallons per 1 minute. 5 gallons per 1 minute. Okay, go ahead and do problem 6 and 7. So for problem number 6, we're identifying the constant of proportionality. Again, it doesn't matter which point that you pick. There's several points that we could pick. We could pick the point 2, 3. We could pick the point 4, 6. We could pick the point 6, 9. It does not matter which one that you pick as long as you are accurate with your y and your x. So remember, the k value for proportionality is going to be equal to your y value over your x value. So if I were to pick the point, let's say I picked this point, I'm going to pick the 4, 6. So if I picked 4, 6, then that means my x is a 4 and my y is the 6. And if I simplify that, that's going to simplify down to 3 over 2. Or 1.5 over 1. So they could write it several ways. They could write it as 3 over 2, or they might ask you to write it as 1.5. Either way is acceptable, but you just have to understand that depending on how they have you write it will determine how you state what it represents. So if I were to write it as the fraction 3 over 2, then that means I'm saying it's going to be $3 per 2 magnets. If I write it as 1.5, then that means I'm saying it's $1.50, don't forget to add that 0 at the end, per 1 magnet. Okay, so depending on how you have it set up will determine how you have to relate it. $3 for 2 magnets or $1.50 for 1 magnet. Okay, if we take a look at problem number 7. For problem number 7, point that I see nice and clearly on here is the point 1, 6. Again, my k factor is going to relate back to my y value, which was a 6, over my x value, which was a 1. So that means it's going to be 6 feet per 1 minute. I'm relating it back to the graph. It's feet for distance, minutes is 1 for time. And that's it. Load it into Google Classroom. You have the rest of your IXLs for that section. It is due on Monday. It is due on Monday. I'm going to give you the nice and lovely grace of that worksheet being due on Monday, but it needs to be finished. Understood? Pack up. Yeah, we have just a couple minutes left before you have to transition.